So far, we have learned several differentiation rules. We learned the constant rule, the power rule, and also the sum rule, difference rule, and the constant multiple rule. These rules work when functions are added, subtracted, or multiplied by constants. But now, we are going to look at what happens when two functions are multiplied together. For this situation, we need a new rule called the product rule. Let's start with an important idea. The derivative of a product is not the product of the derivatives. In other words, the derivative of f times g is not equal to f prime times g prime. Instead, we must use the product rule. Suppose we defined a function h of x equals f of x times g of x. This means the function h of x is the product of two functions f of x and g of x. The product rule tells us that the derivative is h prime of x equals the derivative of the first function times the second function plus the derivative of the second function times the first function. A simple way to remember this is the derivative of the first times the second plus the derivative of the second times the first. Now, let's apply the product rule to an example. We want to find the derivative of the function f of x equals 2x to the fifth times 4x squared plus x. Notice that this function is the product of two expressions. The first function is 2x to the fifth, and the second function is 4x squared plus x. So we will apply the product rule. The product rule says we take the derivative of the first times the second function. Plus the derivative of the second function times the first. Next, we need to take the derivative of 2x to the fifth using the constant multiple rule and the power rule. We have 2 times 5 times x to the 5 minus 1 multiplying by the second function plus we'll take the derivative of 4x squared plus x. We differentiate each term separately. Derivative of 4x squared, we use the constant multiple rule and the power rule, which is 4 times 2x to the 2 minus 1 plus the derivative of x. X has an exponent of 1, and we use the power rule for this, so we have 1 times x to the 1 minus 1. And multiplying by the first function. Next, we need to simplify this. 2 times 5 is 10, and 5 minus 1 is 4. So we have 10x to the 4 times 4x squared plus x plus 4 times 2 is 8, and 2 minus 1 is 1. So we have 8x to the first plus 1x to the 0 times 2x to the fifth. X to the 0 is 1, so I have ax plus 1 here. So my derivative of f of x is 10x to the 4 times 4x squared plus x plus ax plus 1 times 2x to the 5th. Sometimes we stop here, or sometimes we simplify further depending on the problem. Now let's extend this idea a little further. So far, we looked at the product of two functions, but sometimes we may have the product of three or more functions. For example, k of x equals f of x times g of x times h of x. In this case, the derivative is found by taking the derivative of each function one at a time, while keeping the other two functions the same. So the derivative becomes k prime of x equals f prime of x times g of x times h of x plus f of x times g prime of x times h of x plus f of x times g of x times h prime of x. So the idea is similar. Each term takes the derivative of one function while the other functions stay unchanged. So we learned the product rule, which helps us find the derivative when functions are multiplying together. The key idea to remember is the derivative of a product is not the product of derivatives. Instead, we use the formula derivative of the first times the second plus derivative of the second times the first. We also saw how the rule can extend when we have more than two functions are multiplying together. Next, we will continue learning more differentiation techniques that make solving derivatives easier. Previously, we learned about the product rule, which tells us how to take the derivative when two functions are multiplied together. Now, we'll look at another important situation. What happens when one function is divided by another function? For this case, we use a rule called the quotient rule. Let's begin with an important idea. The derivative of a quotient is not the quotient of the derivatives. In other words, the derivative of f over g is not f prime over g prime. Instead, we must use the quotient rule. Suppose we have h of x equals f of x over g of x. This means f of x is the numerator or the top function, and g of x is the denominator or the bottom function. The quotient rule tells us that the derivative is h prime of x equals f prime times g minus g prime times f all over g of x squared. This formula may look complicated at first, but it becomes much easier when we remember it in words. In words, the quotient rule says, take the derivative of the top times the bottom minus the derivative of the bottom times the top and divide everything by the bottom squared. The most important thing is to always keep the order correct because the subtraction matters. Now, let's apply the quotient rule to an example. We want to find the derivative of the function f of x equals 3x squared plus 1 over 4x minus 3. F of x is a quotient of two different functions, So we are going to use the quotient rule. The top function is 3x squared plus 1, and the bottom function is 4x minus 3. The quotient rule says f prime of x equals the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. The derivative of the top is the derivative of 3x squared plus 1 times the bottom, which is 4x minus 3, minus the derivative of the bottom, which is the derivative of 4x minus 3, times the top, which is 3x squared plus 1, over the bottom square, which is 4x minus 3 squared. Next, we need to find the derivative of 3x squared plus 1 and the derivative of 4x minus 3. To take the derivative of 3x squared plus 1, we need to take the derivative of 3x squared and the derivative of 1 separately. The derivative of 3x squared is 6x, and the derivative of 1 is 0. So we have 6x plus 0. Multiplying by 4x minus 3 minus. To find the derivative of 4x minus 3, we need to take the derivative of 4x and the derivative of 3 separately. The derivative of 4x is 4, and the derivative of 3 is 0. So I have 4 minus 0. Multiplying by 3x squared plus 1 over 4x minus 3 squared. Now, let's simplify these two expressions. 6x plus 0 is 6x, and 4 minus 0 is 4. So the derivative of the function f of x is 6x times 4x minus 3 minus 4 times 3x squared plus 1 all over 4x minus 3 squared. If the question only asks you to find the derivative, you can stop here. You don't need to simplify it further unless the question asks you to. The quotient rule helps us take derivatives when one function is divided by another function. The key idea to remember is the derivative of a quotient is not the quotient of the derivatives. Instead, we use the formula derivative of the top times the bottom minus derivative of the bottom times the top, all divided by the bottom square. With practice, this rule becomes much easier to apply. So far, we have learned several differentiation rules. We learned the power rule, the sum rule, the difference rule, the constant multiple rule, the product rule, and the quotient rule. But in many problems, we will not use just one rule. Most functions require multiple rules working together. So this section is about combining differentiation rules. In real problems, functions are more complicated, and we need to apply several rules step by step. A good strategy is to differentiate in the reverse order of operations. That means we first look at the outside of the function, and then we work our way inside. This helps us decide which rule to use first. Now, let's look at example 6. We want to find the derivative of the function h of x equals 2x to the third times k of x over 3x plus 2. Let's first look at the overall structure. This is a quotient because we have one expression divided by another. So the first rule we need is the quotient rule. Then in the numerator, we have 2x to the third times k of x. That means we also need the product rule. And to differentiate 2x to the third, we also need the power rule. Now, we'll take the derivative of h of x using these rules in this order. First, we start with the quotient rule. We take the derivative of the top times the bottom minus the derivative of the bottom times the top, all divided by the bottom square. Next, to take the derivative of 2x cubed times k of x, we need to use the product rule. The derivative of the first times the second plus the derivative of the second times the first. So this is the derivative of 2x to the third times k of x multiplying by 3x plus 2. Next, we need to take the derivative of 3x plus 2. The derivative of 3x is 3, and the derivative of 2 is 0. Multiplying by 2x to the third times k of x. All over 3x plus 2 squared. The derivative of 2x to the third is 6x squared. Multiplying by k of x. The derivative of k of x is k prime of x. Since we don't know what k of x is, we just leave it as k prime of x. K prime of x times 2x to the third is 2x to the third times k prime of x. And multiplying by 3x plus 2 minus 3 plus 0 is 3, and 3 times 2 is 6. So I have 6x to the third times k of x. All over 3x plus 2 squared. So the derivative of h of x is 6x squared times k of x plus 2x to the third times k prime of x multiplying by 3x plus 2 minus 6x to the third times k of x all over 3x plus 2 squared. At this point, we already found the derivative. If the problem only asks you to find the derivative, you can stop here. You do not need to simplify it further unless the question asks you to. So the main point of this page is that some derivatives require us to use more than one rule. In this example, we used the quotient rule for the overall fraction, the product rule for the numerator, and the power rule inside that product. The key is to look at the structure of the function and work through it one step at a time.